Let us look at the fifth question in the week 8. So they have given that x is a discrete random variable with the following probability mass function. P of x equals to x. For 0 it's 0.1, for 1 it's 0.2, for -2 it's 0.4, for x equals to 3 it is 0.3. And it is 0 for all the other values of x. They are asking us to find the PMF of the function y equals to x square plus 2. This y is directly dependent on x. They are asking us to find the CDF of y and plot its PMF and CDF. And they were asking for P of x less than 3. This is conditional probability question. They have given that P of x is equals to x is equals to 0.1 for x is equals to 0, that is equals to 0.2 for x equals to 1, 0.3 for x is equals to -2, 0.4 for x is equals to 3, and 0 otherwise. To verify that it is the sum is equals to 1, we'll just calculate it. 0.1 plus 0.2 is 0.3, 0.3 plus 0.3 is 0.6, 0.6 plus 0.4 is 1. So the sum is equals to 1. This is a probability mass function. So let's look at P of y is equals to y, small y. We don't know what these values of y would be. Let's calculate y for each value of x there. Y is equals to x square plus 2. This is what given to us. So for x equals to 0, if we substitute there, it would be 0 square plus 2, that would be 2. So for x equals to 0, the y would be 2, so the probability would be same, 0.1. And for x equals to 1, the value of y would be 1 square plus 2, that is 3. So for y equals to 3, we have value of 0.2. And for x equals to -2, if you substitute it there, it would be -2 whole square plus 2, that is nothing but 2 square plus 2, which is equals to 6. So for that it would be 0.3. So for y equals 6, we have probability of that occurring is 0.3. For x equals to 3, we'll get a y of 3 square plus 2, which is nothing but 9 plus 2, 11. We have probability of 0.4. So this is the probability mass function for y. And if you look at the cumulative distribution function for y, f of y would be equals to, this would be 0 if y is less than 2. This would be equals to 0.1 for y equals to 2 until y is less than 3. So until 2 is less than or equals to y is less than 3, we'll have a probability of 0.1. So for y equals to 3, it would be 0.1 plus 0.2, that is nothing but 0.3. For 3 is less than or equals to y is until y is equal to 6. We will have a probability of 0.3, cumulative probability of 0.3. So for y equals to 6 until y equals to 11, it would be 0.3 plus 0.3, which is 0.6. So the value would be equal to 0.6 for 6 is less than or equals to y is less than 11. And the later one is 0.6 plus 0.4, which is obviously equals to 1. For y is greater than or equals to 11, so the cumulative probability would be equals to 1. Plot the PMF and CDF. If you plot it, the PMF would be something of this. I'm writing the values of y there. Y is equals to 2, and this is 3, this is 6, this is 11. This is not exactly equals to scale. So the values of this would be, for y equals to 2, it is 0.1, 0.1, 0.2, 0.2, 0.4. So for y equals to 2, the value is equals to 0.1. For y equals 3, the probability is 0.2. For y equals to 6, the probability is 0.3. And for y equals to 11, the probability is 0.4. And we need to plot the CDF too. For that, let's take the same values 2, 3, 6, 11. These were the boundary conditions. So we'll be taking this until it is less than 2, the probability would be 0. The cumulative probability would be equals to 0. And once it is equals to 2, it would be 0.1. Let's take this 0.1, 0.3, 0.5, 0.7, 0.9, and somewhere around here 1. So this would be, for y equals to 2, you'll be having 0.1 probability, and until it is equals to 3, you'll be having a probability of 0.1 there. So exactly at 3, it would be having a jump until for exactly at y equals 3, the cumulative probability would be equals to 0.3. Here also at y equals to 2, we'll be having the cumulative probability of 0.1 there, and until it is equals to 6, the value would be 0.3, and once we reach 6, the value would be equals to 0.6. So it would be somewhere around here. And until it is equals to 11, it would be 0.6, and once it reaches 11, the value would be 1, and after that it continues on. This is the CDF graph. This is the probability mass function plot. We have one last one, that is, they are asking for probability of x is less than 3 given that x is greater than or equals to 1. So for x to be greater than or equals to 1, the probability would be 0.2 plus 0.3, that would be equals to 0.5. This is the conditional probability for this. The value would be equals to the probability of x less than 3 and x is greater than or equals to 1 divided by probability of x is greater than or equals to 1. That is nothing but, if you look at it, probability of x is less than 3 and greater than or equals to 1, we have only one case where for x equals to 1 of 0.2, so the numerator would be equals to 0.2. For it to be greater than or equals to 1, it could take two values, 1 and 3. So the total probability would be 0.2 plus 0.3, which is nothing but 0.5. So this value would be equals to 2 by 5, which is nothing but 0.4.